In this video, we'll generate the dataset and Taylor series expansion of EXPONDIST, both in the saturation and decay. We begin with the values of lambda from 0.5 to 2. So data validation, list of items, 0 to 2. So 0.5 to 2. So these are values of lambda, 0.5 up to 2. And our value for k is 0 and 1. So data validation, list of items 0 or 1. 0, 1. 0 if it is decay. If this is decay, it should be 0. This is 0. And 1, k equals 1 if it is saturation. Now we generate the EXPONDIST of the decay. So array formula, EXPONDIST decay. So x values, comma, lambda, comma, and 0 because it's decay. And saturation. So array formula, EXPONDIST of the x values, comma, lambda, comma, 1 because it is saturation. And we'll chart this. So insert chart. This time we use scatter chart. So we use scatter chart. And this should be checked. And the series. We will use a trend line that is polynomial to the 6th degree. 6th degree. We'll try 8 if that's possible. No. So 6th degree. And we show the equation as label. And we'll relocate it at the bottom. And we'll size the points to its maximum. Apply all series. The point size will be maximum. So here we have the trend line and the trend line equation of both the saturation in red and the decay in blue. Next, we fill in the Taylor series expansion of both. So it is the summation of a times x to the power n plus k, where the value of n is 0 to infinity. So 0, 1, 2, 3 to infinity. We'll try to get to, well, 12 is still good enough for infinity. Now we enter the Taylor series expansion. Our formula, SERIESSUM of the x values raised to the power n plus k, where n plus k starts from k, incremented by 1 because our values of n are 0, 1, 2, 3, 4 to infinity. So it's incremented by 1. And the coefficient will be this range. That's the coefficient a. And there is no equation on EXPONDIST saturation, so we have to modify this. So edit chart, series, the point size will be maximum. And the trend line for all is polynomial to the 6th degree. And we'll show the equation as labeled. Now in the case of, so the yellow has to be changed to green. So that's the EXPONDIST saturation. So change that to green to match our data set. And the red, the point size will adjust it to none, but the thickness of the line will be maximum 8. So that should be okay. Now we continue with the coefficient, which is array formula, starting with the numerator, negative 1 to the power n, times lambda raised to the power n plus 1, n plus 1 over factorial, that's factorial n plus k. So N plus K. So if K is 0, then it's decay. If K is 1, then it is saturation. Saturates to the value 1, while the decay decays to the value of 1. We'll calculate these regression coefficients using LINEST. To do that, we complete the 1 gamma x matrix. So will be transpose from 0 to 6. That's the power. So we have x to the 0, x squared, x cubed, and so on. Now we complete this matrix. So array formula of the x values raised to the power 0 to 6. Now we can calculate LINEST. So LINEST data y, that's for the decay, comma, data x. Now the Taylor series expansion, which is LINEST data y and data x. And finally, the saturation, LINEST data y and data x. And we'll compare. We'll compare the regression coefficients with our trend line. So here, our trend line is 2, 2, and this will be 0. That's 0. Negative 3.98, negative 3.98, 4.01, and this is 1.99. The coefficient of x squared, that is 3.98, 4.03, 1.99. So x cubed, 2.32, 2.6668, and 1.616 x cubed. And x report, that's 0.886, 1.24, and this is 4.43. And x to the fifth, that's 0.196, which matches 0.38358 and 0.0979. So 0.979 times 10 to the minus 2. And x to the 6, 1.89 to the power 2, 4.76 to the power 2, and negative 9.45 times 10 to the minus 3. So we begin with lambda equals 0.5. The decay saturates to decay approaches 0, while the saturation approaches 1. If we change the value of k from 0 to 1, then our Taylor series expansion becomes saturation. And the values of the green matches to the red. So this is the Taylor series expansion approximates the saturation. Likewise, the regression coefficients are the same. At k equals 0, the blue and the red are on the same trend line and their datasets are the same. The regression coefficients are the same and their trend line equations are also the same. Increase that to 0.8. Our decay starts from 0.8 up going to 0, while the saturation starts from 0 approaching 1. At lambda equals 1, the saturation starts from 0 to 1, while the decay starts from 1 to 0 at lambda equals 1.25. So the decay starts from 1.25 to 0, while the saturation starts from 0 to 1. And 2, the saturation starts from 0 to 1, while the decay starts from 2 to 0. This is an error because we are limited to 12, n to 12, where n should be infinity. If we use a bigger number, this should approach zero. This completes the use of array formula, series sum, LINEST function to generate the EXPONDIST both in the decay and the saturation, and its Taylor series expansion to approximate